Hello students, today we will see the next part of the lesson. This is the direct and inverse proportion. Inside it, yesterday I taught you the direct proportion. Inside it, to identify this direct proportion, I gave you one trick, or I told you one thing to understand. In direct proportion, inside the ratio of two numbers is always constant. Ratio of two numbers is always constant, and one quantity increases, other also increases. This is called as a direct proportion. For that I gave you an example. If 5 students are going for trip, they have to collect how many rupees? 500. Okay, means for one this example is for direct proportion. And then if 10 students wants to go for a trip, how much rupees they have to collect? 1000. One student wants to go for a trip, what is his collection? That is 100 rupees. So here one quantity increases, other also get increase, and one quantity decreases, the other also get decreases, and such a proportion is called as a direct proportion. Okay, then the next term, here we solve some of the examples. Inside it, the number of diameters, if number of diameters are increases, the parts of the circle are also increases. Then here in second example, inside we seen that if the number of notebooks and number of students proportion, we seen that if number of students are increases here, then number of notebooks also increases. Number of student, if you see here, decreases, then number of notebooks also decreases. Here 90, 72, 60, 30. So this is the main identification sign of the direct proportion, that is the ratio is same, and another thing, one quantity increases, other is also increases. Okay, then next, here we solve the example. I told you to solve the practice set number 37. Okay, and when your day is there, at that day you have to come and check practice set number 37 from me. Okay, hard copy you have to bring, means your notebook. Then I will check and tell you these examples wherever you had done the mistakes. After direct proportion, the next it is the inverse proportion. What? Inverse proportion. If you see here, example for inverse proportion, I will give you the best example, that is the Cadbury's example. If I have 10 Cadbury's, and I have to give this all Cadbury's to the students. If number of students are 10, each will get how many chocolates? One chocolate. Each will get how many chocolates? One chocolate. Okay. So chocolate now I had taken here Cadbury. If number of students are 5 and Cadbury's are 10, each will get how many Cadbury's? They will get 2 Cadbury's. How many Cadbury's they will get? 2 Cadbury's. If number of student is 1 only, how much Cadbury's he will get? He will get all the Cadbury's. Okay. So here if you see, you will notice that if you done the multiplication of these two terms, 10 ones are 10, 5 twos are 10, and 1 into 10, 10. Okay. So here if you see what I told you, as we seen in the direct proportion inside, what? The ratio of two quantities is same, but here in inverse variation inside, the multiplication of two quantities is same, means number of Cadbury's remains constant. So this is the example. If one quantity increases, other decreases. One quantity increases, other decreases, and if one quantity decreases, other quantity increases. This type of proportion is called as a inverse proportion. If you see here, number of students here decrease. Okay, 10 students becomes 5 students now, but the Cadbury they are getting, it is increases, means one quantity decreases, other quantity increased here. Okay, but here number of student decreases. Here 1 student, how many Cadbury's he is getting? 10 Cadbury's he is getting, means one quantity decreased and other what happens? It was increased. If number of 2 students are there, suppose 2 students are there, they will get how many Cadbury's? That is 5 Cadbury's. One will get 5 Cadbury's and other will get the 5 Cadbury's. In this way, means quantity, here 1 Cadbury, 10. but here one student, 10 Cadburys are there, but 2 students are there in this condition inside. If number of student increases, if you see here, the Cadbury's number is decreases. So to identify the inverse variation, the most important thing is that if one quantity increases, other decreases, it may be the inverse proportion. And the main thing is that in inverse variation inside, the multiplication or the product of the two term is always same. Okay. So for that, let us see the example. Some volunteers have gathered to dig 90 pits. How many number of pits are maybe here? Same, 90 pits. Pits means small debris for the plants. Tree plantation program. The volunteer digs 1 pit in 1 day. How many volunteers dig 1 pit in 1 day? If there are 15 volunteers, how many volunteers are there? 15 volunteers are there. They will take dash days. So how to find out this? Here 90 upon 15. 90 upon 15 ones are 15. 15 6 are 90. So they will take how many days? 6 days they will take to dig the pits. Now here, if the volunteers are 15 here, if the number of volunteers becomes less, how many? At first 15 volunteers are there, and now how many volunteers are there? 10 volunteers are there. Then how many days required? As you know that one volunteer, 1 day, 1 pit he is digging. So 10 ones are 10 and 10 nines are 19. Means how many days it was taken? 9 days. Okay. So from this you will understand that what? That is, if the volunteers, number of volunteer decreases, number of days increases. Means one quantity decreased here, but other quantity here 6 days, and how many days required here now? 9 days are required. So one quantity increases, other decreases. Then here one more thing is that if you do the multiplication of days into volunteers, how much days is here? 15 6 are 90. So multiplication of two terms means 15 into 6 is 90. How many volunteers are there here? 10. And how many days required? 9. So 10 nines are 90. Here the product of the two quantities is same. Then it is called as a inverse variation. Clear for you? Now then, are the number of pits and the number of volunteers are in the direct proportion? No, they are not in a direct proportion. Why? Because in direct proportion ratio is same, and here the what is same here? That is, its product is same. If the number of volunteers decreased, see here now, the number of volunteers decreased, more days are required. Okay, volunteers at first how many were there? 15, but it was decreased to 10. So here requires 6 days. But if the 10 volunteers are there, 9 days are required. So here what they told you, if the number of volunteers decreased, more days are required. And if the number of volunteers increase, okay, if number of volunteers, instead of this, suppose I will take 30 volunteers. How many volunteers? 30 volunteers if I will take. How many digs we have to, pits we have to dig? 90. So 90 upon 30. 30 ones are 30 and 33s are 90. So here if 30 volunteers are there, how many days are required? 3 days are required. If 15 volunteers are there, how many days are required? 6 days are required. So see here, number of volunteers increased, days decrease. And if 10 volunteers are there, means number of volunteers decrease as compared to 15, then how many days was required? Here we seen it 9. Okay, so here they told you, if the number of volunteers are increased, fewer days are required, means number of days are less required. However, the product of the number of days are same. Okay, for example, 15 into 6, 15 6 are 90. 10 nines are 90, and one more example I took, that is 30 into 3 is equals to also 90. Okay, so this is the example, this is the identification sign of the what? That is the inverse proportion. Okay, suppose here one example they gave you. Suppose Sudha has 48 problems in a problem set. How many problems? 48 problems. You have problem set like scholarship and all in that way. If she solves one problem every day, she is solving one problem every day, she will take how many days? 48, because 48 problems are there. One day one problem she will solve, then how many days required? 48 days. Okay. Now what happen if she solves 8 problem every day? How many? 8 problem. One day 8 problem. Number of problems are constant. So how many days you will require? Number of problems divided by number of days. 8 ones are 8. 8 6 are 48. So she will, when she will solve the 8 problems every day, she will take 6 days to complete that problem set. And if she will solve 12 problems in a day, okay, 12 problems, if he said that I will solve 12 problems in a day, then how many days will require? 48 upon 12. For 12 ones are 12, 12 twos are 24, 12 threes are 36, and 12 fours are 48. So how many days will require? 4 days will require. So here you will notice that the number of days problem solving increases, then what happens? Days are decreases. So this is also the example of which, that is the inverse variation. And here the product is same, means 8 problems when she will solve, how many days require? 6. So 8 6 are 48. If she wants to solve one problem one day, so 48. So 48 ones are 48. And if she wants to solve the 12 problems every day, she will take 4 days. So here 48 is its answer. So in the inverse variation inside, the most thing is that the product of two numbers is always constant. So in this way, today we seen that how to identify the inverse proportion and the based examples on it. Okay, that activity and example we will solve in tomorrow's lecture. So today we will stop here only, and the next part, that is solving of the examples, we will take in our next lecture. And today all of you just yesterday's homework, those who had not completed, complete it and send me. Okay, so today we will stop here only. Okay, thank you and have a good day.